Hi there, I'm Dr. Christopher Pena. I am the Scientific Liaison for the University of Chicago Comprehensive Cancer Center.
I'm Dr. Mekinda. I'm the Assistant Director for Cancer Education, also at the University of Chicago Comprehensive Cancer Center. Chris and I have been back several times this summer already as part of an effort to introduce you to students from our Chicago Eyes on Cancer program. This is an intensive cancer research training program for high school students and college students who think they might have an interest in a career in biomedicine. So they come to our campus, they work full-time in research labs with some of our faculty who are doing all kinds of cancer research at the University of Chicago. And the program also works with high school teachers who come and do the same kind of intensive research and then take that experience back to their classrooms to teach even more students about the amazing things and opportunities that are in cancer research today.
Great. So today's episode is specifically going to focus on cancer diagnostics and therapy, and we want you to pay special close attention because these are the future cancer researchers of America, and so we're really excited to have them on board.
Yeah, we feel very fortunate to work with these really talented young people who have made this commitment so early in their careers and in their training, but are already making some meaningful contributions to the way that we are improving cancer prevention, cancer diagnosis, and cancer treatment.
And I think our guests are ready to share some of those contributions, so let's go ahead and bring them up here. So we are Chicago Eyes on Cancer. The I stands for Educators and Youth Enjoy Science. You can reach us at our website at cancer.uchicago.edu/eyes. You can shoot us an email at eyes@bsd.uchicago.edu or give us a ring at 773-702-4678. Well, I am here with my first guest, Cora. Cora, welcome.
Hello.
How are you doing?
Thank you.
Awesome. So, today we're going to talk a little bit about cancer technology. It's a really important and interesting field. Why don't you talk a little bit about MR imaging, which is, from what I understand, which your research sort of deals with?
Yes. So MR imaging is pretty much an acronym for magnetic resonance imaging, and it's a technique used in radiology to see what's happening within the body from an anatomical and physiological perspective. And it's really astonishing because it uses magnetic fields, gradients, and radio waves to achieve this in a non-invasive way. And unlike other imaging techniques that currently exist, it does not expose the body to radiation.
Wow, that's really important. I think that those are some serious advantages to definitely consider. So how are you using MR imaging in your specific research?
In my specific research, MR imaging is used to examine the progression of invasive cancers in mouse models of human breast cancer. And the mice were fed different diets. We split them up into 4 groups, one being low fructose, high fructose, low fat, and high fat. And we pretty much just analyze the changes in variables from the MR images. From 8 to 12 weeks of age, they were imaged weekly.
Right. So, we talk about mouse studies, and I think what I want to know, and I think what some of our viewers want to know is, in terms of humans, is there any kind of correlation between a high fructose diet on, let's say, breast cancer incidence and aggressiveness of breast cancer?
Yes. So there has been previous research that highlights that mice fed on high fructose diets do have an increase in body adiposity, also known as fat tissue. And although it may not seem like it, adipose tissue is a highly active metabolic and endocrine organ in the body. And changes to this, especially in the mammary glands, plays a fundamental role in the progression of a tumor. And usually when people are at high risk or with breast cancer or diagnosed with it, it is recommended that they consume less fructose and less fat in their diets to reduce the risk of the breast cancer returning or progressing further. And some do believe that high fructose is worse than high fat, but there is little research to support this claim. And what makes our research so unique is that it looks at different dietary manipulations to see to also help the recommendations that doctors are giving to patients.
Great. I think one other question I wanted to ask you is, what kind of specifically foods would you say are high in fructose?
So those being processed sugars, when we talk about high fructose, we definitely talk about those, not necessarily fruits, which are healthy.
Great. All right, well, thank you so much for sharing that with us today.
Thank you.
Again, we are Chicago Eyes on Cancer. We are a 2-year program for high school and undergraduate students that want to pursue careers or professions in biomedical research or in medicine, we give them the opportunity to work in a lab where they can shadow a professor and do some really amazing things in the kind of research that's involved in cancer biology. You can reach us at cancer.uchicago.edu/eyes. Give us an email at eyes@bsd.uchicago.edu, or give us a holler at 773-702-4678. Now I'm here with Catherine.
Hello.
Hi, Catherine. How's it going?
Good, good.
Good. So, from what I understand, you're in radiomics. Can you tell us
Yeah.
a little bit about what radiomics is?
Radiomics is basically when large amounts of data from features of a breast lesion are acquired through data characterization algorithms. It's an up-and-coming field in oncology and can help radiologists do their job.
So, specifically, how does it help radiologists?
Well, for example, in breast radiology, which is the area that I'm working in, radiomics can be used to help quantify these different features called biomarkers.
So that's interesting. I've heard of biomarkers before. Can you sort of elaborate on what they are?
Well, a biomarker is something that's measurable and identifies a lesion. In breast cancer, some examples of biomarkers are lesion volume, surface area, contrast, and homogeneity, to name a few. Using radiomics, we can determine if these lesions or potential breast cancer cells are actually cancer.
So how can they do that exactly? How does a radiologist know what's going on with that?
Well, we know breast cancer typically expresses certain characteristics. For example, they're normally very heterogeneous. If we use the data extracted from the MRI, we see high values of irregularity, we know that the lesion is more likely to be cancerous.
Wow. So I guess my next question would be is this definitive? Can radiomics definitively tell us, like, this lesion we found right here in this person is cancerous or not?
Well, we've gotten to the point where certain radiomic programs are considered artificial intelligence. You can select the lesion, and the program tells you the likelihood that it actually is cancer, but these programs are only designed to aid radiologists. They're not actually designed to replace them.
Okay, good. I would worry a little
Yeah.
bit if we were replacing them all with robots. So that's important. So what research exactly are you doing in breast cancer radiomics?
Well, with the help of Dr. Sheth and Dr. Geiger, I'm studying the radiomic biomarkers of linear non-mass enhanced lesions.
Okay, so that's a mouthful. What
Yeah,
is
it
a non-mass enhanced lesion exactly?
Well, normally when we think of breast cancer, most of us envision like a large mass. Linear non-mass enhancement is an area of the MRI that's enhanced, but it doesn't show the characteristics of a typical mass. Instead, cancers are identified by other characteristics like their morphology or their shape. I'm studying how effective these radiomic biomarkers are in actually predicting whether the lesions are cancerous.
Wow, so how are you making those predictions? What exactly are you doing?
Well, basically, I'm plotting the rate that the biomarker correctly predicts positive cancer, which is called the true positive rate, to the rate it incorrectly identifies a positive cancer, which is called the false positive rate. A biomarker that's good at predicting the outcome will have a high true positive rate, even when the false positive rate is low. That basically means it catches all the cancer and it doesn't misdiagnose anyone.
Awesome. So you want to be specific, but you also don't want to
Yeah.
give people a false alarm.
Yeah.
Awesome. Well, that's really great research that you're doing. We're really excited to have you on board and to see where this ends up. So thank you so much for coming here. So again, we are Chicago Eyes on Cancer. We are a 2-year program for high school and undergraduate students that want to do careers in biomedical research. We're also available for teachers out there. If you're interested in doing these kinds of research experiences, you can reach us at cancer.uchicago.edu/eyes. Give us an email at eyes@bsd.uchicago.edu, or give us a call at 773-702-4678. I am here with my next guest, Christian. How's it going?
I'm doing well. How are you?
I'm doing all right. So why don't you tell us a little bit about your lab experience this summer so far?
Sure. So I'm currently working in Dr. LaVille's lab, which focuses on looking at leukemia and how it develops in mice models. So they'll typically look at mice to understand how the leukemia is developed, and then transfer that research over to clinical trials and such.
All right.
More specifically, I'm looking at a cell line that they created from the cancerous bone marrow from these mice, and I'm looking for 6 genetic abnormalities which are linked to the cancer.
Okay, great. So just kind of scaling things back a little bit for the audience, what is a cell line exactly?
Okay, so cell line is it's a major tool that a lot of researchers use to study leukemia and well, all cancers really. So basically, what you can do with the cell line is it's immortalized, meaning it'll never die, and that's not the case with the mice that you're working with.
Right.
You know, mice live for typically about 2 years max, and then they're gone. So
Yeah.
cell line helps you study that cancer and continue cultivating that in media and in a flask, so that way you can therefore later on look at how it responds to different therapies that you might think could kill the cancer.
Great. Okay. So you had mentioned you were looking at 6 different sort of genetic mutations. So what are you going to do after you find those genetic mutations in that cell line that
Right.
you're working with?
Okay, so once I find those genetic mutations, well, first I would need to look at the results, and if they are a genetic match to the mice models, then that'll give way for the possibility to look at more therapy-related treatments and see how that relates to what can kill the cancer in the cell line, and then how that can kill the cancer inside the mice. And then ultimately, the final goal would be killing the cancer inside the humans.
Awesome. So let me see if I'm getting this right. So you're the expert here. You got to help me out.
Sure.
So if you have the same genetic makeup in the cell line that came from the mouse, if
Right.
those are identical,
Yeah.
then whatever treatment you give that cell line, you could eventually do it to the mouse.
Right. But the hit rate, it's just, it varies so much.
Okay.
And a lot of times, you'll use thousands of therapies on the cell line, but that won't transfer over to the mouse, let alone the human.
And
So-
probably because there's
Right.
genetic differences.
Right,
But if they're the
right.
same, there's a possibility that that
Right.
could work.
For sure.
Awesome. And then if it works in mice, then we can
Then-
eventually get it started in humans.
That's a goal, for sure.
Awesome. Well, thanks for sharing that with
For
us.
sure.
We're really
Thanks for having me.
looking forward to having this in the future and seeing where it goes. So thank you. All right. So, again, we are Chicago Eyes on Cancer. We are a 2-year program out of the University of Chicago for undergrads and high school students that want to participate in biomedical research. We also offer this same research experience for teachers that want to get involved and really want to learn more about this side of medicine. You can reach us at cancer.uchicago.edu/eyes or email us at eyes@bsd.uchicago.edu or give us a phone call at 773-702-4678. My next guest is Sidney Hike. Sidney, how are you doing today?
Hi, I'm good. How are you?
I'm doing all right. We're getting through this here. Can you tell us a little bit about what you're doing this summer?
Yeah, of course. So I work in Dr. Mollering's lab, and we are dealing with PROTACs. And basically what PROTACs are they're molecules that combine different proteins in the body, one of which would be enhancing cancer growth, cancer tumor growth, and the other which would degrade that cancer tumor enhancer, which will eventually eliminate it from the body. Specifically, we are dealing with PROTACs that would degrade breast cancer proteins, such as estrogen receptors.
Great. So, it sounds like you're working with these different types of proteins and you're trying to get a system in the body to sort of degrade harmful proteins.
Right.
What part of this cancer process does this really qualify as, would you say?
We would qualify this as the early pharmacological or drug-making process. It's the beginning stages where PROTACs can be turned eventually into drugs, as well as other molecules. They can be turned into drugs as well, which will target these cancer proteins and eventually eliminate them from the body. The PROTACs that we're synthesizing are meant to actually become a better version of a drug known as fulvestrant. And fulvestrant is the current drug on the market for breast cancer, but it has its issues, such as it's not orally available. You can't take it in pill form. This is a huge problem because a lot of patients need for drugs to be taken in pill form, but PROTACs are available orally, and therefore that will be a better option.
So what is your specific contribution to this kind of research?
Well, the PROTACs have actually already been synthesized by the lab. It is my job to test them through different experiments and processes known as gel electrophoresis and Western blotting. And basically, those determine the presence or the absence of the PROTACs and proteins in the cell line.
Great. So if you can reduce that amount of harmful protein that's in this, then the drug is doing its job correctly.
Right, yes.
Awesome. Great. So I hope to that this leads somewhere good, and that we can definitely get rid of more of the harmful things in our bodies, and
For sure, for
therefore
sure.
cancer as well. So stick around. We're going to ask you a couple more questions, but first we are Chicago Eyes on Cancer. EYES stands for Educators and Youth Enjoy Science. We are a 2-year program for high school and undergraduate students that want to participate in biomedical research over summer. We are also available to teachers as well who want to partake in that same kind of experience for 2 summers. You can find out more information at cancer.uchicago.edu/eyes. You can give us an email at eyes@bsd.uchicago.edu, or simply give us a phone call at 773-702-4678. So welcome back, Christian.
Hi.
Sydney's still here from last time. So I think what I want to know is, this is both of your first time in this experience, this program, and you're both working in what's called a wet lab. So can you sort of, for people out there, explain what the difference between a wet lab and a dry lab is?
Well, specifically in a wet lab, you're dealing with the actual chemicals and actual biological processes that you can find in the body or out in the world.
And so, like, building off on that, I guess, like, a big part of that is, like, what type of experiments and what type of analyses you're doing. So in the wet lab, what you're doing involves a lot of chemicals and manipulating of different reagents and such. But and like working with like cell lines and running gels and doing Western blots like Sydney. But like the difference between that is that dry labs focus more on data analysis and application, whereas like the wet lab is more like collection and like looking at it there and then.
Great, awesome. So you guys are mainly involved in that part. The past 2 speakers that we had were more on the computational side of things. So given that these really hands-on experiences that you're fully immersed in have been available to you for this summer, what do you plan to do with this sort of experience in the future? How are you going to take it and do something with it?
Okay, well, I can start off. Well, going into the program, my mind was very narrow, and I was like very set on just being a physician. But I think with this, it opens up your world a lot, and you realize how big the world of academia and cancer research by itself is. And I think this will be definitely a big part of, I guess, my undergraduate and graduate research, and I hope to continue my research as well.
Awesome,
Yeah.
cool.
Kind of adding on to what Christian said, I've wanted to be a doctor for as long as I can remember. And going into this program, I was like, I don't want to do research, but I might as well try it, might as well get the experience. And now that I've done it, I absolutely love it. It's definitely a career option that I definitely want to explore going on into my undergrad years, and I want to continue on my research as I continue going through college. However, being a physician still hasn't left my mind yet. It's still something that I can also explore.
Awesome. I'm glad that it's opened up these sort of different career opportunities and avenues to look at. So, yeah. Well, you guys are first-year students, so hopefully we see you back next year with the same kind of lab progress that you've had, and possibly more. So, thank you so much.
No problem.
Again, we are Chicago Eyes on Cancer. EYES stands for Educators and Youth Enjoy Science, and we are a 2-year program based out of the University of Chicago for students, high school and undergrad students specifically, that want to do biomedical research pertaining to cancer biology. We are also available for educators, secondary educators, that want to partake in these same kind of research experiences as well. You can find out more information about our program at cancer.uchicago.edu/eyes, or shoot us an email at eyes@bsd.uchicago.edu, or give us a phone call at 773-702-4678. So, welcome back, Catherine, Cora. How are you guys doing?
Good.
Awesome. So, what's interesting is we talked a little bit about wet lab experiences. You guys are working in a dry lab. So, how would you say the dry lab experience has gone for both of you?
Well, like kind of what they were saying before, my experience has been a lot more computational. I'm doing a lot of data analysis. I have huge data sets, and I'm running different statistical tests on that.
Yeah, similar to Catherine, I'm also looking at MR images, and it's really cool because it puts you in the scenario as if you're a radiologist looking for tumors, and of course they are confirmed by radiology and pathology, but it's still cool to be at those beginning steps.
Great. And so one other thing that I've noticed is that both of you work with two investigators that are sort of partnered together.
Yeah.
What is that like?
Well, I work with Dr. Sheth. She's my PI, and she's a radiologist, so she's in clinic. And then her PI is a MRI researcher, and so they're always collaborating with each other and working on different programs to help more ladies get MRI'd and help them get screened. And so we work very closely, going and doing community outreach things and trying to spread breast cancer awareness.
Right, and it's super interesting because not only are we working in the research aspect of looking at these different technologies, but we have all this amazing research out here, and you could have all the amazing research in the world, but at the end of the day, it's how you're getting that research into the communities that you want to serve. And so that's another thing that we're also working on with getting the community involved in our research. And another project we do have is developing a breast cancer support group at UChicago.
Great. So not only are you just doing the computational aspect and analyzing data, you're also doing another big part of this, which is going out into the community and educating people. So I'm glad that you guys are doing that. Thank you so much. I think the same question that I asked the last two, how will you use this research experience as something that can help you in your career going forward?
Well, for me, going into this, I didn't even know like computer science, artificial intelligence was really an option for cancer research, because a lot of the times when I heard cancer research, I just had like wet lab envisioned. But I really think being able to experience the statistical side has been very interesting, and it's something that I'm really like considering doing.
Cool.
Okay. For me, I've always wanted to become a physician, and I really enjoy doing research, especially at the population-wide level, and learning about the different health disparities that exist, and also indicating which communities are underserved and what we can do to help them. And I think it's important to be knowledgeable of public health research and research in general, because it helps you understand those types of disparities. So patient interaction, you'll be more understanding from the background that they do come from.
I think this program has taught us a lot about the kind of scope of cancer research, because yes, you have people working in the wet lab, and then you have the physicians administering treatment, and then you have people working at the hospital coordinating stuff, healthcare, insurance. And so I think working has been able to put all that in perspective, and the amount of collaboration that's put into cancer care.
Great. All right, so one other question I'm interested in. What has been your favorite part of this program?
Favorite part? I think being able to meet a lot of people. We've been able to shadow different doctors. We've been able to meet different community organizers. We've been able to go to public health seminars. So I think being able to like be exposed to those varying career fields, and also those like different people and their different perspectives has been really fun.
For me, it's definitely being involved in the latest research that's happening, and involved in the different technologies, and also meeting a whole bunch of people that are either MDs, so whether it's shadowing them, or public health researchers, attending lunch and learns, and also the mentor relationships we have within the program.
Awesome. Great. Well, thank you guys for answering those questions. I'm going to bring our other two guests back up, ask them a little bit more since we have some time left over. Again, we are Chicago Eyes on Cancer. We are educators and youth enjoy science. That's what it stands for. We are a 2-year program for high school and undergraduate students that want to do biomedical research in a lab over the summer. We are also available for teachers as well. You can find out more information at our website at cancer.uchicago.edu/eyes. Shoot us an email at eyes@bsd.uchicago.edu, or give us a phone call at 773-702-4678. Okay, I think in our last segment, what I want to ask you guys is, what advice would you give to people that are applying to this program and want to do it?
Wow. I guess if this is something that you are incredibly passionate about, don't hesitate. Don't think that you don't have the skills or you don't have the drive, I guess, to go after this program. It seems very rigorous, but if it is something that you want to do, it is definitely worth it.
Right.
So I guess to contrast that a little bit, even if you're like unsure of what career you want, so I was set on becoming a physician, but honestly this opens up your world to academia and other researchers in like both the clinic and inside the lab. So it's like it gives you a different perspective on the different careers out there. And I think if you're unsure of like if you're sure that you love science and that you can put in the time and effort to learn science and especially cancer biology, then like this is definitely an amazing opportunity for you to learn about all the different career options for them. And even if you're not interested, at least you'll understand that this is not for you and you can pursue something else.
Great. All right. And then I guess the last question that I gave the other group, what is your favorite thing about this program?
Wow, I would definitely say the networking. Kind of what Cora and Catherine said, meeting all of these different people who have a wide range of different professions and just getting to know them and kind of figuring out their process to getting to where they are at, listening to different faculty talk about their research and also how they got to where they're at, and just becoming a part of it yourself. You know, you kind of get a lot more confidence knowing, hey, I can do this, I can enter the
Right.
workplace doing research, or something else that you want to do.
Yeah, I agree with that. The networking is huge. But I think for me what stood out the most was the actual like hands-on lab experience. So in school for us it's a lot of breadth over depth, right?
Right.
So we like cover an entire textbook worth of biology, but we never really hone in on anything. And with this program you get to hone in on a very specific type of cancer and research that's very recent with it. So you read the papers, you run the experiments, and like you ultimately contribute to that research.
Right.
And so that for me is huge because like I didn't even know how to use a pipette coming in, and honestly, just being able to like run my experiments on my own now, because initially I wasn't able to, but now I can run the experiments and I can contribute, and I think that's huge.
Awesome. So you both have really learned a lot from this experience. So yeah, great. Well, I think we're running a little bit out of time here. So thank you for coming on the show, for talking and sharing all your thoughts with us. So again, we are Chicago Eyes on Cancer. We're a 2-year program for high school and undergraduate students that want to do biomedical research, and they get 2 summers to do this. And so this is the first year for everybody who's come on board. So thank you so much.